All right, now we're going to go ahead and work on using the distance on a coordinate plane, and we're going to find diagonal lengths. And we're going to use the Pythagorean theorem to find those diagonal lengths. So it says here, when 2 points on a coordinate plane form a diagonal, remember that's a key word that we've been talking about, path from one another, you can create a right triangle using the 2 points to help measure the distance. We can find the length of the diagonal path by using the Pythagorean theorem. The diagonal path represents the hypotenuse. So it says practice finding the distance between 2 points on the coordinate plane to the nearest tenth. So if it's not a whole number, we're going to round to the tenth place. So the first thing we need to do is create a right triangle. So we have point A and B, if you will. Now I can make a right triangle that's up on top of the line, or we can do one that's below the line. So it doesn't matter because the side lengths or the legs will be the same value either way. So I'm going to go ahead and make one going, remember when you're doing your legs, they have to be either horizontal or vertical. So you have to make sure you're making a horizontal line and a vertical line. So this is my horizontal line, and I just did my vertical line. And if you can see, this is not a right angle. That's not a right angle. This one here is the right angle. And that's important because a right angle tells us what our legs are. So now we need to figure out what the leg distances are. So I can actually count. So we got 1, 2, 3, 4, 5, 6, 7 boxes. That represents leg 1. And then from here, from this corner, so we got 1, 2, 3, 4, 5. So the other leg is 5. And our diagonal we call our hypotenuse, which is the value C in the Pythagorean theorem. So we're going to go ahead and we're going to fill in our formula, a squared plus b squared equals c squared. So I can call my legs A or B as long as they are my legs, which are again adjacent to the right angle. So I'm going to call 7 my a squared, 5 b squared, and then c squared, my hypotenuse, is what I'm going to go ahead and solve for. So now I'm ready to go ahead and find 7 times 7, which is 49, 5 times 5, which is 25, and that will equal the area of my hypotenuse. So we're going to go ahead and find the sum of 49 and 25. That gives me 74 equals c squared. So we need to do our last step. Take the inverse of squaring, which is square rooting. The square root of c squared is c. And 74 is not a perfect square, so I'm going to round it to the nearest tenth, and that's going to give me 8.6. And if you can notice, that is the longest side. If this is 7 and this is 5, 8.6 would be the longest side, which is my hypotenuse. All right, so then we got our next one. We're going to make a right triangle. So I can make it upside down or I can make it right side up. Doesn't matter. So I'm going to go ahead and make my right triangle like so. Again, when you're making your legs, you need to make sure that they are exactly vertical and exactly horizontal. Okay, that's what makes it the legs. The diagonal is our hypotenuse, and our legs are A and B. So we're going to go ahead and figure out the distance of A and B. So we got 1, 2, 3, 4, and 5. So that's a distance of 5. And here we have 1, 2, and 3. So from here to here, from each corner, is 3. So those are my legs. And again, my hypotenuse is diagonal to the right angle, and my right angle would be here, created from the vertical and horizontal lines. So we're going to fill in our formula, a squared plus b squared equals c squared. So my legs are a and b, so I'm going to go ahead and use 3 as my a, 5 I'll call my b, and c squared is what we're trying to find. So 3 squared, or 3 times 3 is 9, 5 squared, or 5 times 5 is 25. That's going to equal our area of our hypotenuse. So like terms on the same side, so we're going to go ahead and add those straight together. Then get 34 is c squared. And our last step is to take that out of the square by square rooting it. 34 is not a perfect square, 36 is, so we're close. So 34 square root is 5.8 to the nearest 10th. Again, I'm going to make sure that makes sense. 5 and 3 are the smallest, which are going to be the legs, and our hypotenuse is the longest, and 5.8 would be an accurate number. All right, and then we have our next one. So again, we're going to make a right triangle, so horizontal and vertical. So we're going to go vertically, straight down until we get to the same spot as this line, and then we go horizontally until we get to that dot. So that makes our right angle here. So my legs are adjacent to the right angle. So I'm going to count how many boxes. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that distance is 10. And then my bottom, which is 1, 2, 3, 4, my other leg is 4. And we're going to find our diagonal again, which is always going to be across from the right angle, and it's our longest length, our hypotenuse. So we got a squared plus b squared equals c squared. And we're going to fill in our numbers. So I'm going to call a 10, b, my other leg, is 4, and our hypotenuse, c, the unknown, is going to be, stays at c squared. So 10 times 10 is 100, 4 times 4 is 16, and c squared. So we're going to like terms on the same side, 116. That equals our c squared. Take the square root. That's c. Square root of 116, that's not a perfect square because 121 would be close to it, so it's close to 11. That would be 10.8 to the nearest 10th. And if you look, that is longer than 10 and longer than 4, so it makes sense that's my hypotenuse. Okay, and then we have one more of that section. All right, it says when using the 2 points shown on the coordinate grid, find the measure of the distance between the given points to the nearest 10th. So we have 1 point here and 1 point here, so we need to connect those points. So if I connect those points, you notice I'm kind of going diagonally. So what value is diagonal, A, B, or C? Well, C is always diagonal. So we need to make a right triangle, so we can move horizontally and vertically to create our legs. So now we have our right angle. So I know my legs are what we're going to find the distance of. So just 1, 2, 3, 4, 5, 6. So the distance of leg 1 is 6. And then we're going to find the other leg, 1, 2, 3, 4, 5, 6. So our other leg is also 6. All right, so we're going to use the Pythagorean Theorem to find the distance of our hypotenuse. A squared plus b squared equals c squared. So a squared, 6, also b squared, 6, and c squared is our unknown. 6 times 6 is 36, both times. And c squared is the value that we're going to find. So we're going to add our 36 and 36, which gives us 72. And to find the unsquared value of that, we take the square root, which is c. And I know that's not a perfect square. 81 is the next perfect square, so it's almost 9. So we're going to put that in our calculator, and that to the nearest 10th is 8.5. And that would give us the side length of our hypotenuse, 6, again, smallest, and the longest is our hypotenuse, 8.5.